Welcome, everyone, to our second meeting of the year, unfortunately on Zoom. We'll have another conversation regarding whether we should be meeting in February live or only on Zoom later on this year. We're going to skip some of the formalities. There's really no point in asking if we have any visitors because it's hard to tell who you are. And if anyone has got an upgrade, we'll take that up again in March. Tonight's program consists of Rob Sherwood, who you've all heard shortly speaking recently. I don't know how much more I can say about him other than the things you've already said. He founded Sherwood Engineering, starting offering Drake upgrades back then, and he's now the foremost tester of transceivers in our hobby. But that's very brief. We're going to start off with John Kanker, who's going to give a short presentation on Trek. Then we'll move to Rob Sherwood, and we'll close the meeting out with Elwin talking about field day preparations. John, go ahead and unmute yourself and ask to share your slides with through your screen.
Let's see. Do you see my screen?
Not yet.
Okay, everybody see that?
No.
Nope.
No. Okay, why not? I have shared my screen, but I don't see anybody here.
Hang on a second, see if I. I mean, sharing is enabled, so it must be on your side. Maybe we can try it later, Brian.
Yeah, why don't we come back to you later after Rob's presentation.
Okay, go ahead.
Okay, Rob, the floor is yours. Why don't you share your screen, whatever you want to show us, and unmute yourself and go. Welcome.
Rob, you have to unmute. Sorry. I cannot do that remotely. No.
Rob, just hold your space bar down. That'll unmute you. You have to hold it down.
On the bottom on the left side is audio. There's a microphone. When you click on that, you unmute yourself.
Okay, there we're good?
Yeah, now it's working. Yeah.
All right, perfect. All right, thank you. Okay, so I assume many of you have been on my website, and I've found out recently there's people making assumptions that are not correct, so we're going to talk about that, interpreting the table, and a lot of other things. Okay, so this is what my website looks like. That's the top 8 radios out of 158. And so just to give you an idea, there's all those columns that have data on each individual radio. So let's go back 51 years. What did we have 51 years ago as far as data on radios? Then, of course, it was a receiver and a transmitter, most likely. So we had sensitivity in microvolts, and that's still used today on sideband. Selectivity, possibly shape factor. Of course, the Collins mechanical filter came along, and then suddenly everybody else's shape factor was sort of mediocre. And there was a term cross modulation that had something to do with it mixing of two AM signals. I haven't heard the term in decades. But in 1975, all this changed due to articles in QST and Ham Radio Magazine. Oh, don't we wish Ham Radio Magazine was still around? So now, what was new 50 years ago? Well, both the league and Ham Radio Magazine defined new things for the ham community. It wouldn't be new for the broadcast world, but noise floor, which was in dBm, and they standardized on a 500 hertz filter. Even if a radio didn't have one that came with the radio, often you could buy an accessory 500 hertz filter. So that just is the standard bandwidth that is maintained till today. And then the two-tone dynamic range measurement, which is really looking for third order distortion products, just like you do if you looked up a transmitter, a transceiver on transmit, and they had third order, fifth order, seventh order, etc. Well, this is the same thing on receive. We really just look at the third order, but you could look at the fifth. But the problem was the dynamic range, and I'm just going to refer to it as DR3, dynamic range third order, only were measured at 20 kilohertz spacing, meaning you had two signal generators, 20 kilohertz apart, and then you looked at the third order product 20 kilohertz below the lower frequency signal and 20 kilohertz above the high frequency signal. But that sort of implied that pileups are spread out over 60 kilohertz, which is kind of silly. So this was already obsolete for the Drake R4C. And so that's what started me doing the different kind of testing. I think the first upconversion radio was the Drake TR7 that came out in 78. And that started a new trend. And really for about 20 years, all we had was upconversion radios, which meant the IF was above 10 meters or above 6 meters. So what was the problem? So the topology of the superhet radios had changed. We had an IF instead of at 8 or 9 or 10 megahertz was above 10 or 6 meters. So the first IF filter was an FM filter, 15 kilohertz wide typically, sometimes as wide as 20, and then lots of gain, and that was the problem. And then a crystal filter at 2.4 and 500 hertz and all that, somewhere between 4 and 11 megahertz. But in a CW contest or de-expedition, the radios that looked like they were playing okay overloaded. So the 20 kilohertz test didn't show the problem. So the next year in 76, I started testing radios not only at 20 kilohertz, which was the standard, but at 2 kilohertz. That got the test signals inside the roofing filter. And that was the key. So the typical 20 kilohertz dynamic range data was 80 to 90 dB, which sounds wonderful, except when we got the two test signals inside the roofing filter, in this case, I picked 2 kilohertz because it went through the roofing filter in the Drake. Well, the dynamic range number was like 65 to 75 with a typical 70, which is a whole lot different than 80 or 90. So where are we today? Well, now it took many years for QST to include the narrower spacing, and they, did 5 and then finally 2, and now of course it's standard. So both my publications and QST and then RSGB, they do test at 2 kilohertz. So there's about 14 columns of data that you saw on there on the website for 158 radios. Of course, some of them are receivers, some of them are transceivers, and mostly transceivers today, of course. What I did was ranked all the radios in the position by the 2 kilohertz number, which would be a CW pileup number. Today, I guess, RTTY. Sideband, it really wasn't an issue. I'll talk about that later. But unfortunately, the hams tend to look at that one column, the 2 kilohertz data, and ignore everything else. And maybe that made sense when you went from a 70 dB radio to a 90 dB radio. But today, there's so many radios that have 90 or better dynamic range that you don't want to just look at one column, mine or the QST or whatever. But it's not an overall ranking, and I think that's misunderstood. People will assume that if I've got radio number 10, number 9 is better. Well, not necessarily. It will be better as far as the 2 kilohertz dynamic range, but everything else is just the data on that radio. Nothing else is ranked top to bottom except that one column. So what happened about a few months ago? I was listening to a podcast, And I just happened to have tested the FTDX1. I tested the Optima, but that's just the higher power transmitter. And the dynamic range on the first sample I tested was 91 dB. And then also an ICOM 705, which I did use for several months back when it came out, tested at 88. And you'd never know the difference there. But the reviewer said because the Yaesu had a slightly better dynamic range, it was also more sensitive. Well, that was nonsense. There's no correlation if you look down there at the bottom. Not that you again would notice on the air, but the ICOM was more sensitive, even though the dynamic range was slightly less. So that's where I realized I need to start focusing on explaining how the table works and what it means. There was another example when the 7300 Mark II came out, and I've published that. I actually have a second sample now that I'm running through the lab. There was all sorts of chatter about the specs. There's two major dynamic range numbers that get published: third order dynamic range and reciprocal mixing dynamic range, which deals with the local oscillators, whether it's a VFO synthesized or a direct sampling radio with a clock. Now, this term RMDR, reciprocal mixing dynamic range, didn't come about till 2012. So it's a relatively new figure compared to third order dynamic range that goes back to 1975. So do you see the problem? The only column that is sorted or ranked is the 2 kilohertz dynamic range one. All the other data has to be compared manually. So if you said, I want to compare the noise floor or the sensitivity, just look it up by model and by type. So, but the dynamic range test, remember I said it was two signals that were originally 20 kilohertz apart. Now they can be 2 or 10 or 5 or whatever you want to test at. It takes two signals that are very well isolated. The RMDR just needs one signal to make a test, one signal generator. So they're just totally different, and the numbers don't coincide one way or the other. What should you not do? Don't choose a radio today by one number. It's so much more complex. Today, there's more than 20 transceivers that have a dynamic range of 90 or better. And 90 is perfectly fine. And what isn't important is, do we want lower noise floor? I mean, the radios are so good, that's not an issue. And the same thing with sideband sensitivity. So what I want to emphasize today is if you're looking at a new rig, the user interface is key. What's going to work for you? Do you have knobs, a mouse, buttons? Is the display small? Is it large? Is it run by a computer? Is it standalone? Take it out of the box and plug it in. Are the ergonomics easy to use, that you don't have to go to a menu to do something simple? So it all comes down to each OEM sort of has their own ergonomic plan, and they're very different. So I'm saying if you're considering a new radio, make use of your club. Probably somebody in the club already owns one. Try to sit down in front of a new potential radio and see how it works. A friend's QTH, or if you've got a ham store, you're lucky enough, like in Denver, you got HRO. So it's a very subjective type of decision dealing with not technical numbers, but how's the radio work? So we're lucky now. The performance of the top 6 OEMs is great. You can work DX and contests and FT8 and whatever with dozens of rigs. 20, 30 years ago, a 100 dB radio was unheard of. Now it's in the middle of the pack of the top 26, which you'll see in a moment. So choices by brand, cost, and size. You aren't going to take a 35-pound radio out to a soda site. So I operated multiple CWA contests the fourth quarter of 2022 with an FTDX10 and an FT710 that are $1,000 and $1,500 radios, not some $6,000 radio. And the biggest difference was the user interface and the ergonomics. So that's what works for you. May not work for me or vice versa. So it was asked earlier, but normally I'm running 7610s at 3 operating positions. But for this 3-month period into 2022, here was the FTDX10 replacing the ICOM at operating position 1. And here's the FT710. It's almost dwarfed under the monitor there. So that was enjoyable. I did contesting, rag chewing, everything just with these two transceivers. So I really got a feel for the strengths and weaknesses that worked for me or didn't work for me. So here's from my website, the top 26 transceivers. Now, this isn't like number 1 to 26 because there's duplicates. We have a K3 and a K3S. We have a K3 compared to a Flex 6700. And then all the direct sampling radios, there's more variation on dynamic range of all the current direct sampling radios because each ADC chip, analog to digital converter chip, is different. Not a lot, but a few dB. So it's helpful to see what the data scatter is. You know, like the FTX1, the first one I tested, it came up at 91, and then second one it came up at 97. Now that's a little more scattered than normal. I'd say 3 dBs, about typical sample variation. So look, they're right in the middle, 99 or 100 dB, and 20 years ago, that was unheard of. But I've had the good fortune of those 26 transceivers to have run 21 of them in at least one contest, mostly CW. Most of my contesting is on either 160 CW or 10 meters CW in the sideband. Sort of the extremes of our bands as opposed to 6 meters, which I don't contest on very much. And there on the VHF, UHF things, it seemed like FTA runs, rules the roost, rules the rules the roost as far as activity. Sideband activity, at least in Colorado, is less than FT8 activity. So how are you going to select a new radio today? Well, I'd say pick something out of that top 26. That'd be a good start. If you're married to one brand, which maybe you've been a Yaesu operator since the 80s or 70s or whatever, just pick one that fits your budget because every OEM of the main 6 has a good product. The price range, though, of new radios today is $1,000 to $9,600. And of course, as I mentioned, the size, I prefer picking up a 20-pound radio and not a 50-pound radio because I'll be 79 in April. So let's look at some lab numbers and see what they mean without the hopefully not making the wrong assumptions that does happen. So noise floor is rarely an issue today because of urban noise. Now I have a house here in Denver. That's where I am right now. But my contest station's out in a quiet zone, out in the middle of nowhere. It looks like Kansas, but it's east of Fort Collins, Colorado by about 50 miles. It's likely that band noise is higher on 15 meters than the receiver noise. And certainly on 10, you might be about equal, depending on which direction you're pointing your beam. So the noise floor might be a little more important if you're doing a summits on the air and you've just got an end-fit half wave. So if you look at some of the QRP rigs, there may be more variation on sensitivity and noise floor. One thing I think you should always focus on, if you can you improve your antennas? Now, I know there's HOAs, limitations, maybe the family doesn't want the antenna in the front yard or something, but the antenna is the most important, and I would say directivity is even more important than gain, because a 3 or 4 or 5 element Geiger can have, 15, 20, 25 dB rejection of QRM and off the side and mostly off the back. So one of the next columns is AGC threshold. I don't think people think about this much, but usually band noise is above the threshold. So in a classic radio, they might be reading S7 or S5 on noise. So consider reducing the overall gain of the radio using the attenuator or reducing the RF gain so that the threshold is 3 to 6 dB above band noise. In other words, I'm saying We don't want the AGC running on band noise. That means that you're tuning the band. Say you're doing search and pounce on a contest or just looking for weak DX. If the band noise is always as loud as a weak signal, it really gets tiring. So play with that. Sometimes even more than that. I've done as much as like 10 dB above band noise for the threshold. That's a trade-off. Now, Flex and Apache have a dedicated threshold setting. So the Flex is a slider left to right, and the Apache is a horizontal line that goes up and down. With the ICOM, your only option is the attenuator or the RF gain. So each radio is different. But it reduces fatigue. If you're operating for hours at a time, if you can reduce fatigue, probably get a better score. Particularly search and pounce, this is really important. If you're running, maybe a bit less, but even though you're running, when things slow down, you don't want if your headphones being blasted with band noise as loud as the next signal that'll call you. Blocking. Every radio will block. In other words, it has a limit on how strong a signal can deal with. But on a superhet, it may be an out of passband signal and it may even be out of band. Like on 40 meters, you've got broadcast stations above 7.2 megahertz. Luckily, they're not as strong in the US as they are in Europe. In Europe, they're just crazy strong. A direct sampling radio, the analog to digital converter chip, has a limited voltage limit. It's not on power, it's on voltage. So if the LC bandpass filter is 2 megahertz wide, you're picking up signals way outside of handband. So that's what we have to pay attention to. Most of the time, though, at least in the US, blocking or ADC overload isn't an issue for your typical operating day. But I say line of sight can be a different story. A number off that column in there would be 125 dB is a good number. That's a typical number for a direct sampling radio, but some of the superhets with a roofing filter, like a K3S, approach 150. Sensitivity, that's the equivalent on sideband with the wider bandwidth, of course, to the noise floor and CW with the 500 hertz bandwidth. With noise floor pretty much being dominated by man-made noise, it's really rare that the sensitivity is a problem. Again, if you've got a small QRP rig on a SOTA site, pay attention to what that model sensitivity is. It's probably okay. Has things changed over the last 50 years? And the answer is no. Most rigs today will have no preamp, preamp 1, and maybe preamp 2. So they're set up so that if preamp 1 typically will have a sensitivity, that's a 10 dB signal plus noise to noise ratio of about 0.15 microvolts with the preamp 1. Well, that's the same value as a 75S3C or a Drake R4C or the whole 4 line or the earlier S line. So this number of 0.15 microvolts is good 50 years ago as it is today. This reciprocal mixing dynamic range, that one signal test to check out the noise in your oscillator or your clock. The direct sampling radio has a clock oscillator, and your local oscillators now are quite clean, but of course they weren't always that way. We go back in time to our Drakes and our Collins and things like that. We didn't have a local oscillator noise issue. We had a PTO, a permeability tune oscillator, or a VFO, capacitor tune, and band crystals. Neither had wideband noise issues, and we didn't really even think about noise being a problem. But then early synthesized radios came along, and we didn't drift. They had general coverage, most likely, but the synthesizers were terrible. So most of the radios, when I was testing dynamic range that were in that time period, it wasn't limited by the dynamic range of the radio from a third order standpoint, but the local oscillator noise was dominant. Luckily now with mainstream radios in the last, I'd say 7 to 10 years, certainly in the last 5 years, local oscillator noise is not a problem. Whether it's a synthesized radio with a superhead front end and then digital from then on, or if it's a direct sampling with a clock. It just doesn't matter today. They're so good. They finally learned how to make synthesizers, like in the TS-890S, a wonderful synthesizer. So if you look at my columns on the radio, you say, where's RMDR? Well, it only came out in 2012 and just began to be published. But I've got data back to 1976. So what I have there is a listing of local oscillator noise in dBc per hertz. Well, that may not be that obvious what that means, but it's just a way in the technical world to measure noise. So if you want to convert the column that's dBc per hertz, subtract 27 dB. So you also change the sign, but anyway, so you go 137 would be 110 RMDR. So the data is there if you want to make it. And it tells you how to do that at the top of that page. Front end selectivity. Most rigs have either a half octave or a handband only LC filter. A few have tracking preselectors, the FTDX 101D, the MP, ICOM 7610, or the newer 7760. I measured the bandwidth of both the Yaesu and the ICOMs on 40 meters, mainly because if you're working CW on 40 meters, you kind of like to know what the tracking preselector is going to do for you for signals, let's say on 7250. Well, the Yaesu bandwidth at minus 10 dB is about 250 kilohertz. The ICOM is 500 kilohertz. Yet I read on reflectors that someone will say, well, I've got QRM 5 kilohertz away. I detune the tracking preselector and it knocks out the QRM. Oh, that's impossible. If we've got a 250 kilohertz tracking preselector filter, it can't knock down something 5 kilohertz away. But what does happen if you detune your tracking preselector, it inserts attenuation, just like your attenuator or your RF gain. But unfortunately, I'm probably never going to convince people that this is reality, but it certainly is a great feature to have. And if you're in Europe, you probably love it. So the main improvement for a tracking preselector is reducing out-of-band commercial signals, like with the signals above 7.2 megahertz on 40 meters. Of course, for field day and all that, you're probably going to need separate bandpass filters. So finally, we're back to dynamic range at 2 kilohertz. So we've got over 20 transceivers that have a close-in third order dynamic range of over 90 or 90 or more. So most hams don't have an overload issue. But when do we do? If you've got a radio with a roofing filter, like the FTDX10, just as an example, they give you about a 20 dB advantage in exceptional cases. Line of sight. There's a ham in Boulder that's up in the foothills, and line of sight into the city is 5 miles away. So if you've got local signals, line of sight, 60 over 9, 70 over 9, it'd be nice to have a roofing filter. Whereas field day, if with the really big setups, not only do we maybe have CW and sideband, but maybe CW, FT8 and sideband. Well, in that case, the roofing filter is really an advantage because the direct sampling radio, just say a 7300 or whatever, flex, K4, there's no way to eliminate CW signal that's going to impact the digital signal. So if I was going to take something to field day and I had a really big setup, 10A or something like that, I'd probably take my FTDX10. And if you're a multi-contest station, even if it's multi-2, the mult station is looking for signals and he's going to be tuning away from the run station and as close to the run station as he can work. So if you've got a 500 hertz or even a 1 kilohertz roofing filter, that's going to help. So when might 100 dB radio overload? Well, let's look at 10 meters as an example because the noise floor of a typical radio today is about minus 130 dBm, and the noise floor of the band noise is about the same. If I'm pointing to JA, which is about 8 dB quieter if I'm pointing to the Caribbean, then the noise floor of the radio would be approximately equal to the band noise with no preamp. So theoretically, it would take a pair of signals, S9 plus 45 dB, it would make a distortion product peak above band noise. Now I spent the weekend, it was a 10-10 contest, which is maybe you don't consider it a contest, but it really is. I worked about 300 stations. I never saw a signal that was 45 over 9, let alone two on the right frequency to cause an intermod product on a weak signal. Not impossible, but just not very likely. Now, if we say, what happens when we go down lower in frequency? Well, band noise is going to be even worse. So I think if you've got a 100 dB radio, there's not much to worry about, unless you're in one of those corner cases where, like Field Day, where there's 10 stations within a radius of 500 feet. WRTC, World Radio Team Contest in Europe, at 40 meters at night, there was some hams running 7610s, and they were kind of shocked, I think, because the overload light was flickering or maybe on constant. So they ran 9 dB of attenuation. Well, that really wasn't a problem. Band noise at night on 40 meters is typically minus 100. Well, the noise floor of many radios, including in this case the 7610, was minus 132. So we've got way too much sensitivity compared to band noise. If I was adjusting the attenuation, I would have just picked 15 or 12. But they were worried that if they had picked 9, which they needed, but more than that, they couldn't hear a weak signal. That's not the case. You want the receiver to be about 10 dB more quiet than band noise. Well, in this case, we'd have at least 18 dB of band noise. They could be attenuated because we don't need minus 132 dBm sensitivity in noise floor on 40 meters at night. That's just silly. So pick something that makes sense. I'd say it as a starting point, just pick 12 dB. So what mistake is most often made? Radios have to be sensitive enough for 10 meters and now 6 meters because everybody's radio now covers 6 meters. Most radios are too sensitive at night on 40, 80, and 160. There's quite a variation, though, from brand to brand. Like the Flex is the least sensitive without adding preamp gain, but they've got up to 32 dB of preamp gain. It's no problem. But its starting point with no preamp has the least gain. Where if you look at an ICOM, it probably has the most gain. So I'm going to have to run attenuation on the ICOM, where in cases where on the Flex I might be running preamp gain. So just need to learn your radio. So what's changed? Up conversion radios replaced down conversion radios, or the low IF radios. Now, a down conversion radio is a generic term. If you're on 160 and the IF's 9 megahertz, it's not down. But that's what we call it, because it's not above 10 meters or above 6 meters. So once the Orion 1 came out, and then the K3, up conversion radios with a high IF and a 15 kilohertz wide roofing filter became quickly obsolete. So both the Orion 1 and the 2, and the K3 and the K3S have a low frequency first IF in the 8 to 9 megahertz range. Now we look at 3 Yaesu rigs, the same thing, and 2 Kenwood models. So really, it's either today direct sampling or it's a first IF radio at the 8, 9, 10 megahertz range. You see the 70 dB, remember I said the range for close in dynamic range was about 65 to 75 dB. Well, the typical 70 dB radio couldn't compete with 105 for a K3S. Now, the exception to the rule was the ICOM 7851. It's been discontinued, but it had a 1.2 kilohertz CW roofing filter at 64 megahertz. And it also had a dynamic range of 105, but it also was kind of pricey. By the way, the new 7760 is a standard direct sampling radio, no roofing filter. A direct sampling radio, by definition, has no roofing filter. If they are a digital type radio, they have a first LO, first mixer, and then go down to some other frequency like 9 megahertz or something. And that's where it probably goes to the ADC chip. So it becomes a digital radio at the first IM. That's below 20 meters typically. So what about direct sampling rigs? Currently, what's on the market have a dynamic range between 87 and 107 with the built-in linearization. It's called dither, and it turns distortion products just into a little bit of noise. The ICOM 705 doesn't have a button for this dither, so I don't know if it's just on all the time, but it has a perfectly fine dynamic range. I ran the 705 on 160 CW, 10 meter contests, both those ARRL contests in December on the year that they came out. Worked fine. Now, I wasn't running QRP. I drove an amp, but from the receiver standpoint, it was like running a 7300. So usually the dynamic range of a direct sampling radio, when you make the tests at 20, 10, 5, and 2, they all come out the same. Not in every case, but typically they do, which makes sense. There's no roofing filter. So what rig should you own? I'm often asked, why don't I run the top Yaesu rigs like the FT101D? Well, I did run the 10, which you saw, and the 710 for that 3-month period. They worked fine, but I preferred the user interface, the ergonomics, the band scope, and the waterfall on the 7610. But that's what worked for me. For me, I want the waterfall to have almost a minute of history because I'm doing search and pounce on the CW. So I work somebody, and there's somebody up the band 1 kilohertz. And as long as I find him and tune him in within about 60 seconds or 50 seconds, I'm ready to work the next station. But some of the waterfalls only last for 15 seconds. So I don't understand that. Anyway, so for me, that's what worked best. But that's subjective. And should have no bearing on what you pick. And that's why I'm suggesting sit down in front of a radio, if you can, to see if it works for you. What transmit differences exist? Well, we've looked at receive issues until now. So what's currently available to clean up our transmit signals? Well, we got key clicks to worry about, sideband splatter, and transmit noise. Well, the big difference right now as far as what's on the market is pre-distortion. Now that means that you take a sample of the signal and then you characterize the PA in the rig or the PA in the linear, and then you distort it so that when you add them back together, they cancel out. So it does reduce the splatter significantly, and I'll show you pictures. So right now, 3 of the top 6 OEMs offer some kind of pre-distortion. The Apache Anon has had pure signal written by Warren Pratt, NR0V, who now lives in Lebanon, Colorado, so I see him monthly. And he's wrote pure signal in 2013. Now it's improved over time, but he's been around a long time compared to everyone else as far as offering pre-distortion. He just called it pure signal. ICOM has had DPD, digital pre-distortion, and that's a generic term, but that's what ICOM's calling it, since November, happened to be Thanksgiving of 2023. Flex has what they're calling smart signal, as opposed to pure signal, currently in beta. There's some differences, but let's look at some real signals to see how much pre-distortion can do for you to have a clean signal, cleaner bands, and be a good neighbor. We've all got to share the bands, of course. So this picture was a screen capture of a QSO that I was in. taken by Tom W0IVJ in Boulder, who happened to be receiver was a 7000, an Apache 7000. Well, ways to clean up a signal, for a while, Yaesu offered Class A, but that's not available any longer, like with the FT-DX101D or the MP. ICOM now has DPD, still waiting for Elecraft to do something, and I've heard nothing from Kenwood or Yaesu. So the signal in the waterfall on top is a 9-year-old Apache 200D driving an amp with the amp being sampled. So we're really cleaning up the whole rig and the amplifier. Well, look how straight up and down that is. Now, of course, to see that well, we need a strong signal and low noise. So the signals are about 30/9. And you can see on the right-hand edge of the Apache, just a couple little spurts of a little distortion that happened, but almost none. You can clearly see some sort of a switching power supply or wall wart or whatever it is, wobble relating in frequency on the high frequency edge, clearly visible. Well, now the signal below, that was me with a TS890S and an Alpha 89. Well, I'm a little bit stronger, as you can see, more purple on my signal, but look at the splatter. Now, I'm not overdriving my processing. I'm not overdriving the Alpha 89, but this is what a typical rig today without pre-distortion looks like, about 50 dB down. So if we can squeeze it in so it looks like the one on top, we could work on 3 kilohertz spacings with a strong signal 3 kilohertz away and work in a weak eye, but not if you don't have pre-distortion. In this case, I get to say I'm better. The picture on top now was me with a 7610 running DPD, driving an ACOM 1000. But look, the ACOM 1000 is not in the correction loop because ICOM does not support that. But look how it looks just about like the Apache. A couple little dots off to the right, but the signal is just a rectangle. Now down below, that's the Flex 6600M driving the Power Genius XL. This was W5AP versus me, NC0B. And you can see it looks pretty much the same with no pre-distortion as my Kenwood and my Alpha. But if you've got a tube amp that's 15 to 20 dB cleaner than your typical LD Moss amp, you can look like the signal on top. Now, when Tom took this screenshot, just the upper edge of the waterfall, you can see the signal starting to go. So if you look up to the top with a band scope, as opposed to the waterfall, you can see that after we go down about 30 dB, we've got all that splatter in there. So we're seeing the same thing on the band scope with the Flex as we're seeing with the waterfall. So wouldn't it be wonderful if everybody looked like the one there in the middle? So a little more details on Apache's pure signal written by Warren. While all the pre-distortion solutions work, not all support a third-party amp in the correction loop. Pure signal has always supported a third-party amp, and all you need is an internal or an external sampler. So like you have an L4B or something like that, put a sampler on it, you're great. Pure signal continuously recalculates the distortion correction. So once it's done a calculation, it uses that until it makes another calculation, and then it would update. There's no manual calibration needed like the ICOM. With the ICOM, you got to calibrate the whole radio with or without the PW2. The ICOM doesn't change at all. And the Flex solution recalculates if you change frequency, which I'll cover in a little more detail here. So ICOM's digital pre-distortion came out November 2023. Both the 7610 and the 77-60 have the pre-distortion option. If I bought, or anyone bought a 7610 when it first came out, and I did in 2017, it was there waiting for a firmware update. Didn't have to spend a dime. And so within an hour of it being published, I had pre-distortion on 3 rigs. But the PW2 is the only amp that's supported by DPD. The PW1, out of luck. Third order amp, third party amps, Alpha, Ameritron, whatever, out of luck. Now you might wonder, well, what difference is there between the resultant signal with the 7760 that's a 200 watt rig and the 7610 that's a 100 watt rig? Well, barefoot, the 7760 is about 8 dB cleaner, but by the time you drive a PW2 in the correction loop, it's a wash because the limit's the PW2. Now, PW2 is good, but it's not quite as clean as the rigs. So the 7760 competes with other 200 watt rigs, and I think there's a 200 watt license in Japan, so a lot of Japanese stations run 200 watts. So we've got the FTDX 101MP, the TS990S, and the Apache Anon 8000 that are 200 watt rigs. Flex Smart Signal, pre-distortion. So as of this month, right now, it's still in beta, and it does not currently support an external amp, but it will support barefoot. The way it works, it runs a calibration. You can do it with just voice, and it'll come up with a calibration, or you can do a two-tone test. But it doesn't, once it's come up with a calibration, it doesn't redo it unless you change frequency by more than 10 kilohertz, or if you adjust the output power. I don't think that matters, but it's just interesting. The pure signal continually recalibrates. The ICOM doesn't recalibrate at all, and the smart signal only calibrates if you move frequency. Smart signal is only supported by the Flex 8000 series that replaced the 6000 series, and the Aurora, which is a 500 watt transceiver. There's two models, or four models, I guess. That's really an 8000 based radio. So important things to consider. We have great rig choices today at reasonable prices. If you can, try to operate something you're considering buying. Few hams have to deal with overload with 90 dB radios, but there are those corner cases. We need Elecraft, Kenwood, and Yaesu to offer pre-distortion for less QRM. I realize that if I'm transmitting, I don't notice that my signal's narrow, but everybody else does. Luckily, with pre-distortion, with a tube amp, particularly ceramic tube amps, you can get most of the improvement if only the rig is cleaned up with pre-distortion. It'd be nice if all of them would support an external amp, but that's not the case. But don't select a radio with one number. Maybe that option or that reasonable decision, 30 years ago makes no sense today. So if you have any questions about my data on the website, I answer my emails. But I find it frustrating when people will make assumptions like the one that compares between the Yaesu and the ICOM. Well, if it's got a better dynamic range, it has more sensitivity. Well, that's just silly. So at the end of the day, when you're operating, whether you're just on the air for an hour or you've been on the air for 20 hours in a contest or pulling your hair out for some de-expedition, at the end of the day, did you enjoy using your radio? It should be fun. It's a hobby. If you were struggling with your radio, consider something else that would be easier to use. So I'll have a PDF that I'll send to your club of this PowerPoint, or you can send an email to rob@nc0b.com and I can send you one. Let me get out of screen sharing here. And we'll go for questions that were possibly typed into the comment section.
Hey, Rob.
Yes.
So I understand that you got the radios at HRO. In other words, you didn't have the ICOM send a pre-tested radio to you for evaluation. Is that true?
That's true. I mean, what you don't want is a cherry-picked radio.
Right.
Now,
Exactly.
Now, Kenwood does it really well. And so they'll have me, like when the 990 came out or the 890, I went into HRO and picked a random box off the shelf, tested it, then returned it to either HRO or Kenwood.
Okay.
The 7300 Mark II Both of those happen to have come. I'm working on the second sample, but there wasn't much difference. That came from DX Engineering. They were nice enough to do that.
Okay.
So
I
I'll
mean,
borrow.
that's important to me because, if for radios like cherry picked, like you said, it could be possibly, peaked out, and you got to get the radios that you and I would purchase, and yeah, it's a real good thing.
And I'll borrow radios. For instance, I needed a Flex 6400. Luckily, someone in my ham club in Boulder had one, so I borrowed it for a week. So I borrow radios. Of course, I own radios that I
Yeah.
just picked. Are just standard off the shelf from DX Engineering or HRO. So yes, that's the thing that there's nothing. I have nothing to give to the community except the my integrity of the measurements are accurate and no cherry picking.
Yeah, and my final comment is, you are absolutely right. The radios these days we're just like splitting hairs. And I think it comes down to aerodynamics, if you like the menu structure and, one versus another. So that's what it comes down to. Because I mean, all the radios are, pretty darn good.
That's right.
I agree with that. So thank you.
Rob, could you give me a little bit of a description of how you pray to store it? What features, what characteristics are distorted?
Well, and you would hope an amplifier would have a linear curve. So it would just be a straight line of input power versus output, and it's not. So pre-distortion, at least of the three OEMs that have it now, they'll take a sample. Now, if it's built into the rig, they're going to feed the right level into the ADC chip, possibly the sub receiver. I know with ICOM it's the sub receiver, so I'm assuming the others are similar. So then a sampled signal at about, let's say, 0 dBm or minus 10 or whatever the right level is, you sample the signal with the ADC chip, and then it goes to the FPGA. And then so you then see you do a comparison between with this, whether it's done continually or just once or every so often, you'll get a correction curve. So let's say it's starting to flat top by some dB or two on the high end, and maybe it's got some sort of distortion on the low end. So then you just invert it in the digital domain. This is all happening in the digital domain, not the analog domain. So then you just sum the correction signal with the main signal being produced in digital world. And then by the time it gets to the amplifier, the distorted signal is the made undistorted by the amplifier, so it cancels out.
That's the part I didn't get. I didn't see the feedback component of that process. But again, in the digital world, that can all be done with the computer chips.
Right, and it all comes down to devil's in the details and how you're going to write the code. See, Warren's been writing code since 2023. I mean, 2023. Is that right? What is it? No, 2013. So his math skills are just astounding. So anybody writing code, it comes down to how complex and how accurate the code is.
Thank you. Now I understand it.
Kind of like negative feedback, but a lot more sophisticated.
Hey Rob, there are some questions on the chat. Did you
Okay.
see that?
Read them off. I don't see them.
Oh, okay. Marty asked, a couple of weeks ago you posted a table on the effect of preamps for various radios on the Flex Radio Smart SDR Groups I/O. You said in an example of a Flex you should be using preamp on 20 meters and above. Would that be on all modes?
Yeah, probably. I mean, that was a slide that isn't in this presentation, but it talks about net gain, a radio with the preamps off, how much variation is there between the brands. And that's an engineering decision, and none of them are right or wrong. They're just different. So the Flex versus the ICOM, a 22 dB difference in net gain with no preamp. Now, if you're in a noisy environment on 20 meters, typical urban environment, you probably aren't going to run a preamp. But when I'm out in my very quiet location, it wouldn't be unusual to run a little bit of preamp gain on 20 with a flex. But since Flex offers up to 32 dB of preamp gain, where most preamps, like with an ICOM, is maybe 10, I mean, probably like 8 and 13. So most radios that are direct sampling have an ADC driver chip that's got either 16 dB of gain or 20 dB of gain. So that in effect is a preamp that's there all the time. Now Flex is different. They're using a different chip than most everyone else uses the same family of chips. So you just have to realize now the K4 is kind of in the middle. It doesn't have as much gain as an ICOM, but it doesn't have as least gain, the low gain as the Flex. But then you don't have any 32 dB of gain for the HF band. Now there is a third preamp for a K4, particularly possibly needed on 6 meters. So you're right. That is a slide that I didn't include today, but once you get used to what your radio is like, I mean, use a preamp if it helps. If it doesn't, leave it off. Use an attenuation on the low bands, particularly with the Yaesu and ICOMs. You have way too much gain on like 40 meters at night. So it just depends on the design the OEM picked, and they're not wrong or right. They're just different.
Okay, thank you. Then we had a question from Jay Williams. Could you speak about the performance of the new ICOM 7300 MK2 and how it compares with the OG?
Sure. Well, feature standpoint, there's a lot of new features. What it was a surprise was it's not tested as high on dynamic range as I expected. So that's why I got a second sample from DX Engineering, and the two samples were 2 dB, within 2 dB of each other. I think the design of the block diagram design, if it was published yet, I haven't seen a service manual or a detailed block diagram yet of a Mark II. I think it's different. The original 7300 had a DSP chip, and they were reusing code from the earlier models. They had a pseudo IF at 36 kilohertz, and then they were reusing code for DSP for bandwidth and everything you can do with a DSP chip. And that was so they could get to market this amazing radio that sold 100,000 of them and more without having to reinvent everything. My guess is that this Mark II doesn't have a DSP chip and is more like a 705. I don't know that, but that's the way the numbers are stacking up. I don't think it's a real practical problem. If you've got an 89 dB radio, you're not really in trouble. But it was kind of a shock that we'll call it the Mark I or the Mark Zero, the lab numbers are a bit better than the Mark II. And of course, I haven't heard anything from ICOM other than there was a lot of chatter for about 3 weeks on the reflector.
Interesting. Okay, what do we have there? Dan asked, would you consider open sourcing your R4Z MAT design specs and notes?
Well, I did in effect. I mean, I've got anybody that wants the PDF of the schematic and the parts, the schematic anyway, could do so. Hammond, I tried to get someone to take it over. At one point, Harbach was going to do it, but my Gerber plots were from really old software. So I sort of said, anybody who wants to convert them to newer Gerber, do so. Well, someone in Germany did. And I thought, okay, then he'll offer at least to sell you boards or sell you kits or whatever. Nothing really came of it. I know he ran some boards, but I heard at least on the Drake reflector, there's nothing going on. So if anybody wants a PDF of all the 5 kits that includes the schematics of what I used to sell for 20 plus years, 25 years, whatever, for R4Cs, just send me an email and I'll send them to you. I'll consider it open source.
Okay. Okay, that was more common. Terminus Lite 2 supports pure signal with Satis and Quick. Okay, and then there was another question. Have you evaluated an ICOM R8600 shortwave radio?
Yes, it's on my website. There's two of them on there because of second samples. And the funny thing is, the one that I own is pretty high to the top, and the one that I borrowed is probably the most scattered between sample A and sample B. It might be 10 dB. I think that was more of a fluke, but I find it's not as sensitive in a real world on an antenna on 2 meters as my 9700 or even my IC 275H. But it's general coverage. I mean, it's from 10 kilohertz or 30 kilohertz, whatever, to 3 gigahertz. So it's direct sampling through 12 meters, and then it's heterodyne down to a lower IF, everything up to 3 gigahertz. So I enjoy having it. I've run, sometimes I wanted to compare FST1 on 630 meters between a loop and my 160 meter Marconi T that I use on 630. So I simultaneously decoded with both the 8600 and the 7610. And sometimes the loop did better, and most of the times the Marconi T did better. But so it's kind of pricey, but it's a nice radio.
Okay, thank you.
Right.
Anybody else has a question? Please unmute yourself and ask.
Yeah, Rob, I just wondered if I understood you correctly on receiving signals. You said to turn the attenuator or the RF gain down to reduce band noise, mostly to cut down fatigue and contests and that, and to cut the band noise down so you don't hear it at all or you hear it very faintly, but so as not to tune out weak signals. And maybe you could describe how you do that, and is it different on the higher bands like 20 to 10 as opposed, I know on 40 and 80 you run attenuation there and 160 as well.
Okay, not quite right. I don't say you want to reduce gain so you don't hear band noise. But let's say, I mean, there's two different types of S meters today. The classic ones, like on an ICOM, a Yaesu, or a Kenwood, the S meter typically, let's just say 40 meters, 80 meters, runs upscale in most environments. So you want to run some attenuation. So the S meters maybe run an S1. But now if you have a Flex or a K4 or an Apache, it's different because the S meter doesn't change as you add attenuation or a preamp gain. It gives you the real signal level. By the way, the ICOM 8600 receiver in DBM mode does compensate and gives you the actual signal level at the antenna. If you add the preamp, it reads the same. If you run the attenuation, it reads the same, which it should. Unfortunately, most of the amateur equipment doesn't do that. So I just want to adjust net gain, however you can do it, RF gain, attenuator, or those sliders for Flex and Apache, so that make band noise acoustically on your speaker or earphones drop a few dB, let's say 6. I mean, that's just by ear. You can measure it, of course, but so that the band noise isn't brought clear up to the AGC threshold. But then occasionally you're going to need to turn the audio gain up. So let's say I'm working 160 with 12 dB attenuation. That's what I typically did. One time I was comparing the 7300 to 2S990S. Well, the 990S only has 6, 12, and 18 dB options. The 7300 only has 1, 20, which is, I think, a mistake. They should have 10 and 20, but that's what it is, even with the Mark II. So what I did was say, okay, I'm going to run the 20 dB attenuator on the 7300 during a 160 contest, and I'm going to run the Kenwood at 18 dB. Now, I'd never done that before. where I ran that much attenuation. Usually it was more like 12. But that was really cool. Band noise was really almost non-existent. Now, of course, it was still there, but I would have to turn the volume control up maybe 10% of the time because the signal was below the threshold that I had adjusted. But it wasn't tiring at all. So just play with it, see what works for you, but just adjust whatever you're adjusting. Just notice that the band noise with no signal tuned in drops noticeably. And I'm sort of
Okay.
suggesting 6 dB is to maybe as much as 10, and particularly for the search and pounce operator. But I think even for the guy running, once it's calmed down that he doesn't have a contact every CQ, that he's not going to want to hear the band noise as loud as the weak signal either.
Rob, can I ask about the noise blanker feature? I've never really had a good appreciation for where it's useful.
You know, I've been asked if I could test noise blankers. The trouble is everybody's noise is different. Now, back in the Drake days, you had on or off, like with an R4C or a TR4C with a noise blanker. Sometimes mobile with a TR4C, the blanker would just almost eliminate line noise. But everybody's line noise is different, and every OEM's implementation of noise blanking is all over the map. Some of them have like 15 choices, and they're just different, but they aren't necessarily progressive. With the ICOM, it's progressive. But then Warren Pratt's code on Thetis, he's got all sorts of options. And one of them is a trained noise blanking, where he's got like a 30 megabyte or 40 megabyte file of different kinds of noise. And then the software goes out and tries to compare what's in the database and what's on the air and pick the one that's going to eliminate the noise as much as possible. It starts to sound a bit like a squelch. So it's different. But so the OEM's implementation is kind of inconsistent. I know a lot of K4 people are complaining that they don't have any new noise reduction, noise mitigation software for a long time. And I don't think Flex has changed much in a long time. So I don't know how to measure it. I mean, I can measure with a pulse generator. Back when I sold radios, what the heck, I'm drawing a blank. But anyway, a brand radio that I sold out of Japan. Uh, if I tested it with a pulse generator, it worked great. But when I used it on the air, it didn't do anything.
Thank you. That helps.
Okay. Anybody else have any more questions for Rob?
I just was wondering, Rob, between the SDR type radios and the hybrid radios like the 101, does either of them do something better than the other?
Well, the hybrid radio, which would be the FTDX10, the FTDX101D or MP, for instance, have the roofing filter. So in those corner cases, you got to ham down the block 10 blocks away, half a mile away, line of sight, and he's 70 over 9. That's going to be a big help. You can probably work stations within, well, let's say 10 kilohertz, assuming his signal's clean. Now, if he has an older radio that's got terrible transmit composite noise or terrible key clicks or terrible splatter, well, you can't do much about that. But I think for the average ham in an urban environment, it doesn't matter. And I don't like the term SDR because I consider a hybrid radio an SDR because it's got an ADC at the IF. And so it's software defined. I mean, every radio is so full of firmware today, but we'll use the term. So it's hybrid super het with the digital at the IF or the standard pure direct sampling. Most of the time they work the same. Now, some of them have the tracking pre-selector, and that can be helpful again in those corner case environments.
Rob, Edgar, I had a question for you about transmitted AM noise. We had a brief conversation about that a while ago, and I wondered if you had measured transmitted AM noise of the Mark II 7300 and compared it to the 7300, or any comments on that?
Yes, I'm certainly doing transmit composite noise. Now, let me explain this. The ARRL, of course, is with their Clean Signal Initiative, is looking for the OEMs to clean up key clicks, which can be done in software, clean up splatter, which can be done with pre-distortion, or clean up transmit composite noise. The FTDX 3000, for instance, is terrible transmit noise. But there's a difference between what you hear on the air and what sometimes is published, and they talk about phase noise. Obviously, phase noise is noise, but in reality, most of the rigs are limited by amplitude noise. If you look at some plots with these $100,000 piece of equipment from Keysight or Roden Schwartz, and you can look at all three types of noise, the phase noise, the AM noise, and the composite noise, which is the sum, that often AM noise is really dominant, at least beyond the kilohertz. So ICOM's publishing a 10 dB improvement at some offsets on phase noise. Now I measured composite noise, which is what you hear on the radio, on the air, about 3 dB better for the most part. So we've got to, hopefully the league can get the OEMs to measure composite noise because that's what matters. So the difference on paper looks better on the Mark II than it is in practice. Now the RMDR is better by about 12 dB, just like they say. So that's a receive thing though, which probably is only phase noise. Now you couldn't say for sure an RMDR in the radio. They said their reciprocal mixing noise is totally phase noise. It probably is mostly phase noise. But anyway, it is 12 dB better at some offsets.
Thanks, Rob. The reason that's of interest, I think, to us is in the case of the field day setup.
Right.
And the KX3s seem to do a bit better than a lot of the other radios in that situation for that particular reason, as far as I understand it.
Well, the problem is the league has published transmit phase noise when it was really they should have been measuring composite noise, but they only had equipment that could measure the phase noise. So for years, if the OEMs even paid attention, they didn't realize that they needed to be measuring composite noise. So there was no competitive advantage to say, well, my radio is 10 dB better on composite noise, which for field day is a big deal because there was nobody measuring composite noise except me. And now the league spent about a year trying to get their Roden Schwartz FSUP to measure both, not at the same time. And then they have to graph it. But so hopefully over the next year or so, that can the OEMs can understand what they need to really be measuring and paying attention to, because if the other guy's transmitter, let's say it's a CW guy and you're doing FT8, 40 kilohertz away, that's a big problem for field day, no question.
Thanks.
Anyone else have a question, or we'll call it a night?
I think we're good, Rob.
Thank you, Rob.
Thank you very much, Rob.
Much appreciated.
My pleasure.
All right.
I'll
Good seeing you again.
I'll shoot you the
Thanks
PDF.
much.
I'll shoot you the PDF of the PowerPoint if you don't already have it. All right.
Great.
7-3.
Good night.
73.
Thank you again.
Bye-bye.
All righty. Mr. Kanker, are you still with us? Yeah, you're there. I see you. You want to try again to share your screen and see if we can make your slides work?
Yeah, so what do I have to do? Just click the share button here and then go to my screen?
Share and then pick the right desktop if you have multiple screens.
You doubled with me. What do I have to do? Just click the share button and go to my screen?
Yep.
Okay. Do you guys see my screen?
No.
Okay. Well, I clicked the share button.
You need to click. You need to select the screen you want to
Yeah,
share.
then
It
and
has
then
multiple steps.
then select screen
He's got
up
to be
in the
the
left corner.
presenter too.
Yeah, no, it doesn't have to. It's enabled. He has to go up in the left corner with his entire screen. Click on that.
I'm sorry, say what?
After you click the share button, you get another screen, and you have to pick one of the screens.
Oh, I gotcha.
Because
There. Now do you see it?
now we cook.
Okay.
Success.
Thank you. Let's rock and roll.
Right.
Okay. So, my name is John Kanker, W9JM, and I'm the Public Service Director for the North Shore Radio Club. And before I begin, I just want to let everybody know that the NSRC is a public service organization, and we participate in several ham radio communications events. And for the new members and for the existing veterans as well, this is a great way to participate and to become active in some of our club events. So what's happening nearby? March 22nd is going to be the Bank of America Shamrock Shuffle. It takes place downtown. You can contact hamradiochicago.org to sign up for this event. Coming up next is June 20th, 2026 is a Truck 100. I'll be talking about that shortly in a bit. You can contact me, or I will be sending out solicitation mailers within the next week or so.
Hey, John.
Yes.
You don't advance your slides, but they don't.
Click on from beginning.
Yeah, you might have to go to presentation mode then and PowerPoint.
He's in slideshow. All he has to do is go to from beginning. It should work.
Yeah, that's right.
We only see one slide at a time. And then you can advance it with the arrow keys or whatever.
Right.
Okay.
That one, yeah.
Yeah, but you want to go
Yeah,
first.
so we got-
Here we go.
So you see that? And you see the
Yes.
second slide?
Yeah, but you're not in presentation mode. We're looking at we're seeing your whole entire
Right.
deck.
Are you seeing the screen move?
Nope.
You're not in presentation mode.
I don't understand. I am in presentation mode, and I click from the beginning. That's my first slide.
Okay, down where your magnification percentage is indicated, there's an icon just to the left. If you click on that, you'll be in presentation mode.
What?
Look on the lower right-hand corner of your window. You see them, not that one, the next one over. There.
Slideshow mode, yes. You go to presentation.
Slideshow mode, yeah, that's what you
Okay.
want.
Okay, you see that now? Changing screen?
Yeah, I need to
No.
go.
No, you went back to the edit mode. You got to click on that again.
Well, I'm in the slideshow.
No, you're not in the present there.
Yeah, I clicked that.
Oh, okay.
Well,
There.
he might have picked the wrong
You might put the
desktop.
wrong screen.
Yeah.
Maybe you
okay.
said the wrong screen.
Okay.
Why don't we stay on that screen here? We done.
Let me see what else is here. I mean, that's all I got. I'm sorry if I can't, you can't see the stuff.
Or you can stay in that screen right now and just click on forward the slides.
You can see this?
Yes.
Okay, we're just going to go from this then. Let me go back up here.
It'll work.
Okay.
That works.
Okay, yeah, it'll work. We're hams, right? We'll just make it work.
We'll work through it.
Okay. Okay, so let's see, where did I go? So our public service events coming up March 22nd, the Bank of America Shamrock Shuffle. Contact hamradiochicago.org for the sign up on that. Trek 100 is June 20th. You can contact me, W9JM at ARRL.net. for more information, or I'll be sending out the sign-up flyers shortly. And the mother of all events, October 11th, 2026, is the Bank of America Chicago Marathon. You can contact hamradiochicago.org for more information. Or I would think Rob should be sending out his sign-up flyers within the next couple of months on that. So on that, in cooperation with the Trek Bicycle Corporation, the Back Fund, and the North Shore Amateur Radio Club, I'm going to be looking to recruit 40 ham radio operators to provide communications for the largest and most prestigious cycling event here in the Midwest. And that is the Trek 100, which will take place on Saturday, June 20th, 2026. So what is it? It's a typical century type bike event. It is, again, on Saturday, June 20th. Takes place at the Trek corporate headquarters in Waterloo, Wisconsin. The thing that makes this so special is, again, it's the largest and most prestigious cycling event in the Midwest. It's huge. Last year's ridership was well over 2,100 riders. And this is the North Shores Club largest public service event that we sponsor. It's a charity event with 100% of all the proceeds being awarded to the MAC Fund. So what am I looking for? I'm looking for some SAG drivers and operators. I'm looking for 15 of them. This is somebody that you're going to drive your own vehicle. You need to be capable of carrying at least one bike and rider. You have to be APRS equipped, and you need to have a UHF VHF radio. We are changing our communications plan for this year. So you'll need to operate on 2 UHF frequencies and 2 VHF frequencies. I'm also looking for SAG navigators. Now, this is somebody who's going to ride shotgun with the SAG driver. We found out last year that we had almost every SAG driver had someone riding shotgun with them. And what they do is they help navigate, maybe help with the radio, help out identifying hazards on the road. SAG navigator is a great position for somebody who doesn't have the radio equipment or is maybe a little bit reluctant to just jump in here and do an event because they don't know what they're ahead of them or what to do. This is a great way to learn the course, learn the ropes, and sit along with in the SAG car and helping the SAG driver. If you want to do this, you just sign up for this, and we'll assign you with somebody, or the SAG driver. If you have somebody that you want to ride shotgun with, just let me know on that on your sign-up sheet as well, and we'll place you with somebody. Looking for 3 or 4 pickup van operators. Now, this is going to be very similar to a SAG operator, except you're going to operate your radio portable, probably from a battery, in one of the real lush and plush Trek vans that'll be driven by the Trek employees. So these are like these are pickup vans. They'll be at the rest stops picking up riders and bikes. And I'm looking for a sweep vehicle. Looking for 5 of them. The thing that you need here is just like a SAG driver, APRS equipped. Need to be able to carry at least a couple bikes. Thing that you need most here is patience, because you're the last guy on the course. You're sweeping up and riding behind the last rider. Now, one thing that I want to say here is, you notice I don't have rest stops and I don't have a couple other positions. I've already contacted a lot of our people for recurring positions that we have for sign up already. You've responded back to me, so I'm already working on those positions. So this is what I'm looking for now, is mostly the on the course stuff. Why is this a public service event? And why is our club involved with this? I mean, this is all the way up in Wisconsin, so why are we doing this? Well, number one, all proceeds from the Trek 100 is used by the MAC Fund. It stands for Midwest Athletes Against Childhood Cancer, to discover a cure for childhood cancer and related blood disorders by providing funding for clinical research. So why are we doing this? Well, way back in 2020, at the request of the MAC Fund, the North Shore Radio Club Board of Directors was presented with the opportunity to take over all the ham radio communications for this event. I brought this information to the board of directors, and I'm glad to say that the board of directors unanimously approved that this becomes one of our events. So the board of directors that was around way back then, thank you very much. So with our help, last year's Trek 2025 raised over $1,221,000. That was some of this came in late, but that's how much we raised. So all of this money goes to the MAC Fund and is going to be used for clinical research. Did you know that more than 40,000 children are in cancer treatment each year, and more than 15,000 children and teens will be diagnosed with cancer in the United States? Did you also know that since 1980, there have only been 3 drugs that have specifically been approved for childhood cancer? Did you know that 95% of the kids who win this fight against cancer have other lifelong side effects from the cancer and/or its treatment? And did you know that every day 43 new kids are diagnosed with cancer? So why should you do this? Well, this is one of our club's premier public service events. You need to be radioactive. Membership in your club should be more than just paying dues and attending a meeting. I'm going to assume you joined this club to be part of the organization. Well, here's your opportunity to participate. And if not me, then who? Since this meeting started, 2 children have already been diagnosed with cancer. This could be your child. This could be your grandchild. This could be somebody you know. How would you feel if you heard about that? But most importantly, because every kid that's battling cancer is someone's child, someone's sibling, someone's grandchild, and someone's friend. It's some little kid. They didn't ask for this. So these kids need our help. I always put this slide up in every one of my presentations because it really, to me, really hits home of what I'm looking for here. When I first started to take over the managing of this event, one of the volunteers from this club, from the North Shore Club, came up to me and said, "John, this is really such a noble cause and I need to help. I'm not a doctor and I can't cure people and I don't have the finances to significantly help on my own. But I'm a ham and I can use my skills and equipment to help the Trek 100 raise money for these kids. I will gladly give up one of my days to help this fundraising effort, a day that some of these kids just might not have. You count me in for whatever you need me to do and for whenever and wherever you need me to do it." Now, that's the kind of person I'm looking for. And I can point to a handful of people that are out here in this Zoom session that would come up to me and tell me this exact same thing after they have participated in this event one time. So this is an amateur radio public service event. If there ever was a public service event, this is it. A lot of clubs have what they call public service events. They park cars. They help with traffic control. They do this, they do that. This here is a huge charity event. This is, if you ask me, the poster child of a public service event. And the North Shore Radio Club is very proud to participate in this. I want you. I want you to join my team. You can go to the macfund.org or trek100.org and get more information on the event and on the charity. You could contact me at w9jm@arrl.net for any questions. Volunteer sign-up information will be in the email soon. You guys, help me cure childhood cancer together. And this is a great event. And I think if you talk to anybody in our club who has done this, they'll tell you the same thing, and they come back year after year. That's it. Anybody have any questions? Excellent. Brian, meeting's back to you if I can turn this thing off. Yeah.
I love it. I love it. Thank you very much, John. And
Okay.
I just want to reiterate one thing, in that we are a public service organization, and this is a major event for this club. So please participate. Next up on the agenda is Elwin, who is going to talk a little bit about an event that we occasionally participate in, something called Field Day, is it? Elwin, why don't you take the floor?
Thank you, Brian. Hopefully we're not going to be in. All right, let me see here. I gotta take the right screen. This one there. All right, can you see this?
Yes.
Yes.
Yes,
Good.
success.
Yes. Okay. Well, all right. Thank you very much. Field Day, our annual Field Day. The preparation has started. And for you who are new, what is Field Day? So Field Day is an annual 24-hour amateur radio event, and it is sponsored by the ARRL. There's a lot of activity involved, and we're going to try to get people to help with this. This is a big thing. So I'm also recruiting. Now, this one is a little later than I think John's event, if I'm not mistaken, or is it earlier? I forgot. And it's in June, and I'll get there. But so please take a look at this on the website as well. So where are we? We started the preparations. We had our first kickoff on January 27th with the core team, with Udo, Brian Nolan, Jay, and myself. The dates are June 27th and 28th, and it is going to be held at Clarkson Park in Northfield, Illinois. Our next steps are like the next meeting to February 24th, where we're going to also invite the captains for the different domains that need to be organized. One key milestone has already been achieved. Thank you, Don KK9H, for reserving the location. So I think that one is ticked off on the checklist. Thank you so much. Those are the areas that we are going to need captains for. We have, thanks to the recruiting of several people already, many names in the boxes, so to speak. We still need some captains, and a captain really is going to be the lead for the area. And we will work with the captains, the core team will work with the captains to go through what all needs to happen. We obviously will help with the recruiting where we can. But the intent is to have a captain for every area, because those are the areas that need to be organized for Field Day. And so if you see an area where you would want to lead, please feel free to connect with the core team. And if you see already where you would want to help, feel free to connect with us too. But we are going to have specific campaigns to recruit people for volunteering in the areas as well. I think last year, the organization was very successful with sign-up sheets and different waves of recruiting, and we're gonna keep doing that. So that was very well done last year. I'll stop here. That's kind of what I had. I just want to create the awareness with everybody. Please let Udo, Jay, Brian Nolan, or myself know where you're interested in helping out, and then we'll schedule you in, obviously. And if you had questions about what is required from you at that point, we can help you with that too. That's all I had. I hope it was brief and at the same time clear. Anyone had questions for me?
Yeah,
All right.
everybody fell asleep already, I guess. Just want to mention that we will again send out direct email to the membership when this was soliciting helpers for the specific areas, and also there will be sign-up sheets on our website as last year. Not only for helpers, also for the operation, single sideband station and the CW stations. So that will happen in the next couple of months. And where you are asked to sign up and reserve your seat, so to speak, for the.
I have a question.
Yes.
Is there a certain shift or whatever that you tend to need more operators, like daytime or mornings or night?
Yes, there will be sign-up sheets with hours, operating hour blocks, where you can sign up and reserve your slot, so to speak.
Okay.
That will happen. It will be published on our website and will be published through direct email to the membership.
Thank you.
All right. If no other questions, back to you, Brian.
One quick question. I noticed that on the list, the antennas for sideband was left blank. They're still around somewhere. We're using the same ones, correct?
Oh yeah, but it's not meaning the physical hardware. We're talking about who is leading the effort.
Yeah.
Okay.
Yeah.
There was a list of captains, Eric.
Okay, I got it.
Are you going?
Did I hear, Eric, you're volunteering to be the captain for the sideband antennas? Is that what you're trying to say?
I can certainly help put them up on the Friday before.
Yeah.
Super. Thank you.
Eric looks like he's going mining or something.
I'm just getting ready to take the dogs out. It's my dog walking light. And I might go into a mine too. Who knows?
Right. Okay.
All right.
Brian, you have anything else?
I'll probably be doing the same thing, walking my dog too.
Yeah.
Just want to thank everyone for participating tonight. At one point, we had 51 people on the Zoom.
Yep.
So that is like a major coup for us to have that many people at one meeting. And thank you all for participating. And I guess we'll call it a night. Thank you again. 73.
73.
Yeah. Good night, everybody.
Good night.
We'll end the meeting now.
73, everyone.
Bye-bye.
Goodbye.